Hi, Algebra 1. So this is on page 203, 204. These first couple of problems we need to be able to do by hand, not using Desmos. So the first thing is I want to figure out what the slope of this equation is, which is right there. So my slope is 5, but I want to find the line perpendicular. So the perpendicular slope, that's the upside down t, means it's going to be negative because it was positive here. I'm going to flip 5 over 1 over to get 1 over 5. This is my perpendicular slope. From there, I'm going to plug into this equation. This is x1, this is y1. So I'm going to add, this is a -1, so it becomes a +1 here. My perpendicular slope I'm plugging in. This is a +3, so it'll be a -3. So this is the equation that is perpendicular to this equation. And this equation also contains this point if we had graphed it and looked at it. Number 2, a couple things to note. Because this x value is 0, this means this is our y-intercept. Okay, if the x value is 0, the number in the y position is the y-intercept. So right now, if we had y equals mx plus b, so far I know I have y equals mx plus 2. So now I just need to find the slope. So remember the slope equation's this. This would be a good equation to make sure you have written down so that x1, y1, x2, y2. So the slope is equal to 12 minus 2, -3 minus 0. So that's going to be 10 over -3. Let's plug our slope into our equation. And there it is. Problem number 3. This is kind of a goofy one. So think about a vertical line, right? Vertical line goes straight up and down. So that's normally x equals. So you just look at whatever your x value is. So x equals 7. That's the equation. You don't have to worry about anything else. You can't find the slope of it because there's only one point. Slopes for vertical lines are undefined. Number 4. So we want to find the equation that is parallel. Those two lines like that means parallel. So I have a slope of this being 6. So a parallel slope is the exact same thing, which is also 6. Okay, that's not an 11. That's meaning that they're parallel lines. Okay, what did I say on the last problem? If x is 0, then this becomes our y-intercept. Oh, cool. We can just go ahead and do this. So y equals mx plus b. That's what we're going to plug into. We know the parallel slope is 6. The b value is -1. That's our equation. This equation is parallel to this equation, and this equation also contains this point. Number 5, we want to find the line that passes through the point. So I don't have any special cases here. None of the points are the exact same. So I'm going to go x1, y1, x2, y2. My slope equation, I'm going to go y2 minus y1 over x2 minus x1. Make that a plus. So I'm going to get -7 over -5 plus 3 is -2. So my slope is 7 over 2. All right, then we're going to use this point because we're going to plug in a y1 equals m times x minus x1. When I plug in, it's going to be opposite, so that's a +5 here, it's a -5 here. 7 over 2. That's a -3, so it's a +3 here. Okay, for 6, 7, and 8, we're actually going to use Desmos, okay? And I'll pull up Desmos, just have to load it. So for problem number 6, remember on Desmos, I'm going to hit this plus button, go down to the table, and I'm going to plug in those values. So I have -12, and then I have -27, I have -9, and I have -15, I have -6, I have -2, I have -3, I have 6, I have 0, and 21. I have 3 and 30, 6 and 42, 9 and 58, and 12 and 67. So remember, if I can't see all my dots, you're going to go down to this little magnifying glass where it says Zoom Fit. You click that, and all of a sudden you can see all your dots. So let's figure out our line of best fit. So I'm going to go Y1 because our top value up here is Y1. And I'm going to use tilde, so shift next to the 1. That's a little, it's called tilde. MX1, I'm using X1 because this is X1 here, plus B. And this, my friends, is my line of best fit. So if you look at it, it says, use a graphic calculator to find the line of best fit. That's all we have to do is find the line of best fit. Our line of best fit is really Y equals, the slope they gave us was 3.92778x plus 20. That's our line of best fit. That's our equation. We don't have to look about the correlation or anything like that, but that's our line of best fit. Okay, where this is the slope, which is a big ol', it's a big ol' decimal. All right, number 7. Let's plug our data in. Let's get rid of this. Get rid of our data. You can keep the equation there because it's going to work for us on this next problem. All right, so now I'm going to plug, this is problem number 7 on the bottom of page 203. So I'm going to plug in -4 and 15, -3 and 12, -2 and 5, -1 and 3, 0 and -5, 1 and -10, 2 and -13, 3 and -20, 4 and -23. All right, so because we have this already set up, look at my line of best fit. It's Y tilde, or Y equals, we can do that because we already have the tilde above. My slope is -4.95. X minus 4. There's your line of best fit. That's your equation. All right, we're now on the top of page 204. So let's clear out our data. You don't need this anymore. All right, so this talks about a child and how they grow in years, how tall they are in inches. So when they are age 1, it looks like they are 24 inches tall. When they're age 2, they are 28 inches tall. When they're age 3, they are 33 inches tall. When they're age 4, they are 38 inches tall. When they're age 5, they are 41 inches tall. When they're age 6, they are 45 inches tall. When they are age 7, they are 48 inches tall. When they're 8, they are 51 inches tall. And obviously this doesn't keep going as you grow. So my equation is, let's see, that's for sketch graph. We have that there. Use your equation to calculate the height of the child when they are 0 years old. Okay, so 0 years old, if I go x equals 0, notice that line comes up. Make it a little darker. I'm going to change the setting here. So when they are 0, it looks like they are 2.929 inches tall. Use your equation to calculate the height. Oh, we already did that. Was letter B. Letter C. Use your equation to estimate the height of the child in 12 years. Oh my gosh, 12 years. So let me go y equals 12 on here. Let's see what happens. So do you think at 12 years old you're going to be 67.786 inches tall? That's a little goofy. That's pretty tall. It's for a 12-year-old. And then what does the slope represent? The slope is 3.9. Okay, so that means you grow 3.9 inches over every 1 year. That's all it means. You can go ahead and skip number 9. Let's not worry about that. What we're going to be working on for the rest of the period is I will be putting up on the board some things that you would probably want on the sheet of paper I give you. You can use the sheet of paper I give you in class and write anything down you want, even example problems, okay? But I'll put some key features that you definitely want to have for the test. Have a nice day, everybody.